Hello and welcome to Intermediate Algebra. In this video lesson we talk about multiplying polynomials. Some of this you have seen before, but it needs to be reviewed because you need to be very accurate in your work in doing this. So we'll start with the simplest case where you just have a number, -2, times a polynomial. And a polynomial is made up of one or more terms that has a variable raised to an integer exponent. You can have more than one variable. There are other videos posted in Blackboard that help you tell what a polynomial is and go back over how to figure out what like terms are. We're not going to deal with that here though. So what I have to do is I have to take this -2 and multiply it by each of the terms. Terms are separated by addition and subtraction. So here I see I have 1, 2, 3, 4 terms because they're separated by 3 addition and subtraction signs, and I'll have 4 terms in my answer. So first I do the -2 times 5, and I get -10x to the 4th. Now notice I kept the sign of the -2 and kept the sign of the 5, multiplied them together. A negative times a positive is a negative. Then I do the -2 times the -6x squared. So I multiply the numbers together. And then I would multiply any variables together, but there's only an x squared, so that just stays as is. But I get a positive 12 because I had a negative times a negative. I do -2 times positive 6, and I get, positive x, and I get a -2x. -2 times -12 is a positive 24. So that is distributing the -2 through the polynomial. That is probably a very simple example. Most of you got that right. You have to watch the signs though. If there's a negative outside your parentheses when you're done, the signs you have in your answer should be exactly the opposite of all of the signs in your problem. So I started with a positive 5x to the 4th, and I have a negative for my first term. My second term was negative. My second term is now positive. So I check the third term. Yep, the third term is negative. Every term has changed sign, so that means I've distributed the negative correctly at least. Okay, so let's move on to another way to do this one. I'm going to take the same example and show you a way to set it up, because the way I set this one up works very well with more complicated examples. I'm going to set this up using what I call boxes. And I would have drawn on my paper something like this. I would have drawn, so I have one row for that, and 1, 2, 3, 4 columns. And it doesn't matter if I make 4 rows in one column. I could flip it around the other way, but I tend to do the first thing is my rows, and the second quantity is my columns. So I need one row with 4 columns, so I would draw a box like that. Now PowerPoint here gives me this wonderful box template I can put in, so I'm just going to use that, and I'll erase this so that you can see better. Now the way I set this up is I take the first quantity involved, the -2. I'm multiplying a -2 times something, and I write it in my first row. So if that had been -2 plus x, I would have written -2 plus x here. Then my next quantity that I'm multiplying is 5x to the 4th, and I put each term kind of above its own box. -6x squared plus x minus 12. And if I had had more than one term than -2, I'd have written each term in its own row. What I'm going to do is I'm going to fill this box here with this column times this row. That's exactly what you do when you distribute. You did -2 times 5x to the 4th, but this gives you a visual layout for where your results are coming from. So let's fill that in. -2 times positive 5 is a -10 x to the 4th. Pardon the handwriting, it'll get better as I get better at making these. -2 times a -6x squared, that will go in this box here. That gives me a positive 12x squared. Now I just have a number out in my row here, so all my x's are going to stay the same, all of my variable terms. -2 times positive x is a -2x. -2 times a -12 gives me a positive 24. And what I have here is my answer is actually written in these boxes. Let's try to erase a couple things, make this clearer. So my answer is right here. And that should be the same as I had on the last slide. And as you can see, every sign is changed from what it was in the polynomial in the parentheses. Now this works very well when your problems get more complicated. This isn't much more complicated, but now we have a 3x squared out in front. So I am going to write my 3x squared here, and that's my row. So I have one row times 4 columns again. 5x to the 4th minus 6x squared plus x minus 12. So in this box here, I'm going to distribute the 3x squared times 5x to the 4th. It goes here, 3x squared times 5x to the 4th. The row and the column intersect, that's what I multiply. Well, we're all pretty good about getting the 15. But what I don't know that you remember is this. When I multiply x squared times x to the 4th, that gives me x to the 6th. I add the exponents when the x appears twice. That's because x squared is x times x. X to the 4th is 4 more x's multiplied, and when you count them all up, you get x to the 6th. So you add the numbers on the exponents. That's different than raising x squared to the 4th power. We won't deal too much with that. For now, you just have to remember that you add the exponents. If we were going the other way, if we're doing x to the 4th over x squared, you would subtract the exponents, as we'll see later. So this gives me 15. Get back to my color here. X to the 6th. Negative 6 times 3 is 18. It's a negative 18. X to the 4th. Positive 3x squared times positive x will be plus 3x cubed. Don't forget there's an understood 1 on that x. And then 3 times negative 12 is negative 36, and there's no x's to multiply, so that's what I get. And my answer appears here. So that's a way to organize your work. So you're not, I don't like looking back and forth. I'd much rather look in this two-dimensional pattern. So let's take a look at another example using this method that's a little more complicated. So now I have a binomial. I have two terms here times my polynomial. Let me go to a better marker. So this time I have two rows, and I would have just drawn this. If I were drawing this on a piece of paper, if I didn't have this lovely template in front of me already, I would have done this. And then next to the first row, I would write 3x. And then next to the second row, I would write negative 2. There's my first thing I'm going to multiply. Okay, and then above, 5x to the 4th. I'm going to erase this because it's going to get busy, but you get the idea. So I'm going to write the 3x minus 2. Oh, sorry, I messed that up. Minus 2. And I'm going to do 5x to the 4th minus 6x squared plus x minus 12 on top. So that's my problem. I haven't done anything yet, but rewritten my problem in a different form. In this first row, first column, so that's the columns are above, the rows are beside. I have 3 times 5 is 15, and x times x to the 4th is x to the 5th. Then in the box next to that, to the right of that, I still have the 3x as my row, times negative 6x squared is negative 18x cubed. Then x times 3x is 3x squared, and I should be in the habit of writing the signs, especially in the middle terms. Negative 12 times 3 is negative 36. Negative 2 times 5x to the 4th is negative 10x to the 4th. Negative 2 times positive 6 is times negative 6, sorry. I was thinking ahead. Positive 12x. Let me write that better. Positive 12 x squared, because it's just a 2 outside, so all the x's are going to stay the same in this row. Negative 2x plus 24. Now, you say, well, where's your answer? Well, I'm not done yet here, because I have to group like terms. And the nice thing about this is the like terms are easy to see. I go to look for the highest power first. I see I have a 15x to the 5th right here. So my answer is going to be 15x to the 5th Now I look to see, do I have any x to the fourth terms? I have an x to the fourth term here, but I don't have any others to add to it. Minus 10x to the fourth. And then x cubed, there's only one of those, minus 18x cubed. 3x, okay, I get down to x squared. I have a 3x squared, I have a 12x squared. That becomes a plus 15x squared. And then I have a minus 2x. Pardon my writing down the side here. I didn't plan my space well. Then for constants, the only x term is the minus 2x, and then I can add these two and get a negative 12. So this is my answer. So you would write that out in one nice line underneath. Probably you wouldn't need to go down the side because you would have more to work with for paper than I have screen. But that's how you lay that one out. Pardon the handwriting, that will get better as I go along, but this was the best way I knew to show you today. All right, let's take a look at the next example. Now, you're all probably pretty good at foiling, but if you forget to do stuff when you foil, or you forget the order, you get mixed up, you can use this for something simple like foiling. I'm going to write my 3x minus 2 here, my x minus 12 there, and now the x times the 3x goes there, 3x squared. That's your firsts. The negative 12 times the 3x goes here, which is negative 36x. That's your outers. X times negative 2 is negative 2x. There's your inners. And your last is negative 2 times negative 12, which is positive 24. And if you have all of your degree, like this, these are both first degree. I have an x and a constant present in each of them. Your like terms show up in the diagonal. It's kind of neat the way that works. So I get 3x squared minus 36 minus 2 is minus 38x plus 24 when I do that. The reason I show you this is also going to be a way to look at factoring. If I figured out that I needed to break this up and then this negative 2 times negative 36 into negative 36 minus 2 here, I could factor using this layout. I would put my terms in the boxes and my common factors would go up top. And that is very useful also. But this also just keeps your work straight. It keeps you organized in a way that writing things out in a straight and one horizontal line does not do. All right, that's it for multiplying polynomials. We will have another video on dividing. Thanks. Bye.